Welcome to this presentation on phase shifting deflectometry. My name is Wedgbrow and I am the Business Development Manager for Micro-Epsilon here in the UK. You may have seen the videos on social media from the BMW car plants which show a fully automated paint inspection and repair in their production lines. This seminar aims to introduce you to the technology behind the inspection and why the car plants look to incorporate such a system within their line. So why look at this technology? Defect detection on reflective surfaces is often carried out by human inspectors. However, human inspection can be an expensive resource. Think of the time to train, how long to inspect, the number of inspectors and the number of shifts needed to fulfill the production. Human inspection also has many variables to consider. The quality of work is dependent on the skill and experience of the inspector. The time of day has an impact on physical condition of the operator. It is also very easy to become fatigued, especially when inspecting for the finer defects. Automated inspection can remove these issues. To date, visual surface inspections and quality control processes have been carried out by auditors. However, only 65% of all defects can be detected by visual human inspection processes within an acceptable time period. The more time invested, the higher the detection rate. But even under offline conditions, not more than 78% of all defects could be found by the human inspector. When we incorporate inspection technology, we can achieve much better inspection rates and in a fraction of the time. It gets worse depending on the colour of the surface, because this also impacts the ability of the human inspector to find the defects. Even when you get well-trained operators, the comparison from one auditor to the next is quite variable. So you can already see that taking away the onus from the operator inspection to incorporating some automated visual inspection saves time and, in the long run, money. So what are we using to automate this inspection process? reflectCONTROL is, as the name suggests, a measurement system for inspections on reflective surfaces like flat mirror-like surfaces, and is used for 2D and 3D surface inspection. It consists of a large screen that projects light patterns onto the surface, which is evaluated by two cameras located in the housing. The video will show the sinus pattern in action, the light pattern on the surface, and the resulting data capture in the software. By analysing the signal received from the projected sign patterns, we generate a number of 2D images that can be processed by vision tools. In addition, the data points can also be used to construct a 3D representation of that surface being inspected. The 2D images consist of a basic intensity image, which represents the brightness of the object and is most similar to the image you might see with a normal vision camera. The amplitude image is created from the reflective properties of those sine waves on the surface and highlights defects that change the reflectivity. The third image is the so-called curvature image, which is used to detect surface structure changes to highlight dents and scratches. Using the deflectometry technique allows us to identify and categorize even the smallest of defects, as these examples show. The real clever part of the inspection, though, comes from the 3D construction of the surface from the captured sign patterns. These images on display are nominally flat, but actually the smallest of curves or bends can be picked up. It is this ability to construct the reflective surface in 3D and then make the measurements for quantifiable data on defect size and depth that open the door to the fully automated inspection and repair. A common approach to measurement of defects on a surface is to scan that surface with a high precision point sensor, such as our confocal chromatic. Here, a surface of 30mm by 30mm has been scanned with a confocal sensor having a 400 micron range and spot size around 3 or 4 micron. The sensor has been scanned across the surface to build up this detailed surface. The capture time is around 30 minutes. On the surface there are two defects. The first is a defect which has a 20 micron depth. The second is another defect which has a 30 micron depth. Now we will capture that surface using the reflectCONTROL. The reflectCONTROL sensor captures the whole area in less than 1 second. If you compare the scaling, it's the same result. So you can see there is a huge time saving and comparable data when using reflectCONTROL. Here we compare the deflectometry against the interferometer. The difference between the images when compared is down to 8 nanometers, which is really showing the true capability of the measurement using reflectCONTROL. So let's get back to the paint inspection. The process chain looks like this. Within the car plant, the car model is planned and simulated using software tools to define the robot path and inspection sequence. The car is then inspected with reflectCONTROL sensors, and results are made available for identification of trends and possible failure modes within the process. Results are also passed to the automated repair station for inline repair of the identified defects. So let's see all of that in action. Because the car body can be in slightly different positions, we first use reflectCONTROL to locate the car body with a 6D position correction, which looks at X, Y and Z and rotational elements such as the pitch, roll and yaw. The colour of the vehicle has limited influence on the system for inspection, but we can run specific settings for each colour if needed. In order to give maximum coverage on the vehicle, we are inspecting up to 108 areas per car body. The time per position, including robot motion and image acquisition, is around 1.4 seconds. depending on the number of robots used. The cycle time can be less than 60 seconds and we can process over 60 vehicles per hour. Micro-Epsilon holds a patent on the process of doing inspection using 3D data for classification of the defect, which gives real height values and is the key to unlocking the automated repair process, which needs to know whether the defect is above or below the surface and by how much. The density of defects or clusters can be used to determine or highlight issues within the assembly process. Other examples of uses for reflectCONTROL include smartphone inspection, flatness of the screen, and defects on the rear side. Inspection of protective screens and covers, looking at the flatness and also defects on the surface. Inspection of optics and mirrors, again for flatness and surface defects such as scratches, dust and nicks. Even semiconductor wafers, again flatness and surface defects can be detected. I hope you enjoyed this short insight into the reflectCONTROL technology. If you have an application or would like further information, then please visit our website www.micro-epsilon.co.uk, or you can email us info@micro-epsilon.co.uk. Thank you for watching.